Today's open source technologies have really transformed industrial automation. That said, using open source is free in the same way that a puppy is free. You're pretty much on your own when stuff breaks or if you need new features. The good news is with agentic coding tools like Claude Code and an industry full of really smart developers, open source communities are doing a really good job at bringing these platforms forward. And honestly, it's never been a better time to start using open tech in the industry. I want to show you what this looks like in practice. So I'm going to walk through an example for a company that is a sheet metal roll forming operation. So they take large rolls of 26 gauge steel and make roofing and siding panels along with trims and all that good stuff. So we're going to have a CRM that's going to be an interface for sales teams and our customers, an ERP that's going to let us plan and schedule jobs, a data collection layer that's going to connect to PLCs and SCADA systems to help visualize real-time data and store history in a data warehouse, a machine learning platform that trains on historical data so we can run local inference, and finally an agent that can answer our questions and do some ERP tasks for us. So I want to explain how this agent actually works. I'm running a local LLM here called Qwen 2.5. It's the 14 billion parameter model, and there's different models, different kinds of models for different use cases. The smartest and most expensive models are obviously running at the frontier labs like OpenAI and Anthropic. This is just a local model that I'm running offline here on my PC using an open source tool called Ollama. Ollama is great for building harnesses and agentic AI without leaking data to another company or adding security risks to your local network. Obsidian is a free tool that runs on a local directory of markdown files. And the cool thing about Obsidian is that you can connect notes together and form sort of a graph. So this is what I mean by a knowledge graph. So I'm in Obsidian here now, and I can see, let's see if I can make this a little bit bigger. I can see I've got Kansas City here, which is a location. Here's my company. So I've got process knowledge. So I can go in here, and this is just a collection of markdown files with links to each other, right? So I have this markdown with all kinds of different fault codes, machine states, and this is just process knowledge. So I can go back to my bigger graph here. I can see here's Kansas City, and where's locations? Here's locations, and here's Tulsa. So I can see Kansas City is kind of out on its own, and it has its own machines. I can go into each machine, and I can see the metrics that we collect for each machine, and specifically, details about that machine, the person who installed it, the people to contact about it. And agents love this kind of graph because it gives context into any question that you have. So if I have a question about Kansas City, or if the agent has the ability to go look at the data and determine something went wrong, specifically the Kansas City shear machine, I can go figure out what all the metrics we collect for it are, what they all mean specifically, if they're related to anything else, who to contact about them, specific rules about the data to collect. So for instance, I can go in here and just say tracking error is slow on this machine for some reason. Contact Chris if you want to help fix it, right? So I can go leave this note, and now the agent will go find this note and understand what it means and put it into the context of this node on the graph. You can also say something like, this is how you get data for this. You can have a little SQL query in here that says, select from tracking error, right? Select timestamp from tracking error. So this is a super useful tool when you're using agents. Anything with a graph where you can traverse and an agent can go gain relationships and understand kind of the context of what they're seeing, I think is a great tool, and agents really work well with that. So if you don't already know, an MCP server is basically a tool, like an API basically, that an agent can be made aware of, so it knows that you've given it the ability to perform actions on your behalf. Basic actions or tool calls could be things like checking your email, making updates in an ERP system, anything like that. The purpose of a well thought out MCP server is to define a contract for an agent and give them specific abilities. We aren't really ready for agents to run dark factories here in the US or anything like that, but there's no reason an operator should have to go pull up a bunch of systems to solve a problem or just to make some kind of a simple update. Another great building block on top of all this data is a machine learning capability. So machine learning can get very complicated, but practically speaking, we can use the data that we collected, and maybe if we have 5 or 10 or 100 examples of that happening, we can train machine learning models on that data to see if there's any metric or combination of metrics that behave in a certain way leading up to a failure. Then we can install that machine learning model to do real-time local inference on production data, and that will help us work towards preventing those failures or just being more prepared knowing that they're about to happen. So I'm going to jump over to my screen here and show you what I'm working with. I've got Portainer running here as one of my services. It's going to manage my other services. I'm not sure what's going on here with this one, but these are all my services. So I've got EMQX. EMQX here is my MQTT broker. So you can see I'm receiving messages here. I've got messages in, messages out. I'm publishing messages here to one topic, and I'm subscribing to that topic. So this just kind of shows, the connections and the messages coming through. Now I'm using Node-RED to connect to that message stream and then kind of do something with it. So this flattens the tag rows. This inserts into a tag history table, which is PG tags, and that's in a timescale DB Postgres table. Same thing with this one, detects state changes. So anytime the state of a machine changes, that's going to go into a state event table. From my other screen here, I have my CRM set up. It's just a real simple page. So I'm going to create an order. So I'm going to say 48. I'm going to submit the order. That just creates an order in my CRM. You can see it shows up here in my ERP, and I can view it. I can see that it's scheduled to start and finish a few minutes later. So down here, I've got a dashboard in Grafana, which is another open source tool just to kind of visualize data. The MQTT broker is constantly receiving and publishing messages, and those are being streamed through Node-RED into the correct Postgres tables. So this is kind of pulling that location. It kind of lets me show what's happening in the operation. You can see I have line status. I have Tulsa line 1, which is line speed, inches per minute. So I've got 250 there on Tulsa, so I can see that one's running. I've got machine health here. Coil weight remaining, so that's the amount of steel that's left on the coil before it runs out on the machine, needs to be replaced with a new coil. Shift totals, so I've made 2 parts so far. Availability is low because I let this sit here for a while before I started it, so that should continue to rise. Total pieces too, so I've made 2 pieces. You can see my production state change table here. They were all idle until that line switched to running. So this is just changes in the production state. That's that second data flow from Node-RED. Okay, now that we're in progress, what I'm going to do is simulate a unplanned downtime event. So I'm going to open a terminal, and I obviously have this already set up, but I'm going to just basically simulate a line going down here. Okay, I can see my line just went down. I can see the line speed, went to 0. Now Tulsa 1 is not producing anything. So I can see on this side, this should refreshes every 30 seconds. So I'll refresh that. Yeah, so we have line down. Production was interrupted. Tulsa line 1 has unplanned downtime. We can also see down here in the state change table that that line went from running to unplanned down. Now, if I was at the plant, I would just go try and figure out what happened, right? Go ask someone, go let someone know that the line is down. But we have this agent here that we can ask to go investigate. So we can say, what happened at Tulsa 1? So it went to go look. Looks like it queried the database and came back with, this answer. We went down. We already know that. Kind of some more info. So yeah, what caused this? Or we can say, could have caused this. So now what it's going to do is go, you can see it queried production again, and it went and actually searched the knowledge base. So it doesn't look like it found any additional information. So we're going to say, okay, we'll figure it out. Go move this to line 2. Okay, so it's going to go make a tool call, and it's going to reassign the currently interrupted work order from Tulsa line 1 to Tulsa line 2. And it should go ahead and get that started on line 2. Okay, I can see we're started on line 2 there. I'll come in here. Yep. Okay, I see line 2 kind of picked that up. Yeah, so line 2 has an active line speed now, and we should start producing parts off of line 2. Yep, line 2 changed to running. So we had a line in production, right? And that line went down. So we asked our agent to go look at the data and figure out, if it could, see why it happened, or just kind of give us the time of when it happened or what happened. And it went ahead and queried production data and then looked through a knowledge base to figure out if it could get any additional info. Didn't really have any additional info other than the line went down. And then we went ahead and asked the agent to go ahead and interact with the ERP system and move that order from line 1 to line 2. And I'm actually just going to demonstrate the knowledge graph here since it didn't give us anything useful. What metrics do we get from the machines at Tulsa? So it's going to check the knowledge base for me. Hydraulic pressure, sensor data, dry belt condition. These metrics track common issues, stacker jams, and roll former faults. So I just wanted to demonstrate that I can go, traverse a knowledge graph and get things about my specific operation. So just to recap, I want to reinforce open source tech is moving really fast. It's certainly not always the answer, but if you're looking into capturing data to solve particular problems, there really has never been a better time to start doing that. Step 1 is obviously data collection, getting visibility into the current state of your operation. Step 2 could be adding agents and machine learning to help solve particular problems. If you ask me, collecting and storing data is really the most important thing we should be doing right now in 2026. Now, this is what I do, so if you're on this journey and could use some help, email me at chris@signaliiq.com. Thank you for watching, and we'll see you next time.